Well, I'll mention that it's a great presentation, and we need your guys' help making our presentations better. We need to do PowerPoint slides. It's really nice.
So permission to treat the witnesses as hostile?
Yes.
So as part of the requirements given to you, when Mr. Patrick said, hey, we want you to do that, did he mention that the CubeSat would have a payload in it, right? Because a CubeSat takes something up. Apparently Beanie Babies was how they came up with that. I didn't realize that. That was an interesting piece of information. So did y'all consider as you were designing that you would need room to put something inside of there? Because it seemed like your mechanism really constrained a lot of the internal volume for the CubeSat.
Yeah, that's one main reason that we printed kind of multiple CubeSats, because we wanted to make sure that on like our first few prints, they didn't have as much, space, and we even thought about that. We knew that when you send them up into space, you'd want, so you could send out into space and collect all the information. And so that's why we started another CubeSat, I guess with the red one, but so we can make the sides smaller, and so we could have more space in the interior of it, so we can have more room.
And did you consider at all when you were putting together? I noticed in the design slides you had for the different cross sections for the walls, you had a whole bunch of different designs in relation to that. Some circular, different members.
Mm-hmm.
What was your thought process on how you determined what you came up with was the right one to do?
Well, we looked at everybody's CubeSat and we figured out like some had triangles, some had circles, some had an X shape. So we were like, we picked like their best CubeSat and we picked our best CubeSat.
And we knew that, because I know Patrick said something that the triangular shape was like
The most stable geometric
shape. So we took that into consideration to our design.
Did all of y'all agree on that at the same time?
Yes, we actually did.
We had to like gather up and make consensus.
Really? That rarely happens. Usually it's his job to choose.
Yeah, sometimes in systems we do what we call crate studies. It's basically a tool to help us make decisions as a team. And sometimes it's easy, it's obvious what the answer is, and sometimes it can be a very complex formal process.
So would you describe what you created as a door?
We basically just kind of made it so that if it had hinges, it would just flop out.
Okay, so there was some thought to
Yes.
Because right now I see an escape hatch.
Yeah.
One thing you should consider, just for future, is this gets into what when you go up and launch, they tend to put CubeSats in areas that are not designed for vibration, for getting shaken. So you generally have to deal with some really intense, really hard shakes. So you've got to make sure that the hinge design type approach may be something you want to think about for future designs. Because otherwise, when launch, maybe your door flies off and kind of gets jammed in the dispenser or things like that. But vibrations is always a problem that I think a lot of CubeSats don't tend to really think about until they get to the test side of things.
That's a really good point. We're putting secondary payloads on the first launch of SLS, and they are 60 CubeSats. And the mission is not designed around the CubeSats. They're along for the ride. So they are not in an ideal location on the launch vehicle. They're in a really hostile environment. But they are not going to change that. They're just along for the ride. So we have to kind of deal with what they get.
I had a question. I assume the white, this was to represent your solar panels?
Yes.
Did you, what was your thought process about putting it on all of these sides? Do you know why you did that?
Yeah. So, I mean, in space, you never know what's going to happen theoretically. How do we say that?
Theoretically.
Yeah, you think that it's supposed to be that way, but on paper it's different than real life. So there's always these different elements. So we decided, like, if the sun's shining on one side and not the other, and when we put it on, if you put it on the other side, you won't get any power.
Exactly. That's a very good thought process. You never know what the orientation is going to be. So, we've learned to, in most cases, we fill that outer shell with as many solar cells as we can, because you never know the orientation, and you can never have too much power. So, very good.
I'd like to ask on, you mentioned that you went through a process for improving your 3D printing. What kind of thoughts did y'all have initially when you first saw that your first print wasn't good? How did you come to that affecting temperature and flow rate were the right ways to fix the problem?
The group as a whole kind of worked on it.
Yeah, because we knew like all groups, we knew that everybody was kind of scratchy and kind of weak. So we knew that I think Mr. Lipsy was talking to, I think you, Alex, about temperature increases and being able to slow the time down to where it would print slower and just make the CubeSat even better and stronger as a structure.
Excuse me, I have one question. Hi, I'm Marcy Cleveland from the External Relations Office, and just applaud each of you, every single team, and Patrick, of course, and this wonderful team. Just curious, did you come up with a leader, or did you all just start your process together? Did you start looking to, did somebody kind of decide, well, I think we should do it this way, and everyone followed? You know, the leadership and working together as a team is so vital. It appears that you all did very well.
Well,
Yeah,
what
I
we
think
did was-
we did decide to like say, all right, we're getting into two groups, and like we're gonna do this and this and this, and like everybody would like do their own piece, and then like we'd come together and like say like, oh, we did this and we did this, and like we'd like, okay, and like come help them about like what we need to change and like all that stuff.
So teamwork was very
Oh, yes.
Yes.
Yeah. 8th graders kind of led us in the beginning because nobody knew that what they were doing. So the 8th graders, they had already taken the class,
That's great.
and so they already knew about the robot, you know, the coding.
Robo-Pro.
And that really did help us get through the year. That's why.
Because we could all bring our knowledge, because each person had their own knowledge of something. And if somebody didn't have the knowledge of that, they could always bring that knowledge into the whole group and just help and bring everything together.
That's terrific. Again, congratulations to each of you. It's amazing. My friend Susan Curry from the Academic Affairs, is thrilled to hear.
I'm absolutely,
Speechless.
I'm absolutely speechless. You guys have done some great work. I taught school for a long time, and I think this is superior to anything that I saw in presentations in the past. I love your presentation.
Oh, I love presentations.
We all need to
Yes.
learn how to do that presentation.
I want to say one thing for the kids that you're seeing today. This happened during an enrichment period. They received no grade.
Oh.
They received there's nothing on their record that they did this. But 152 kids at Robertsville asked to do this class, and their teachers kind of helped me put this group together. So we're coming back next year is the plan. We're going to do it again. But they didn't get anything for this except just to
It's a wonderful experience
That's a pretty
and,
cool
you know,
thing.
a meeting with some of our finest Marshall engineering team. Thank you.
Where'd the name come from?
We put all of them.
All right, we put our names together. Like,
Okay, all right.
All the other groups had names, and so we're like, we have to have a name, but it has to be unique. And so we just thought of putting all the names to first letters together.
No. Just go.
So,
See all of our
Yeah.
names.
Heslin, Liza, Taylor, Heston.
so for y'all, was this your first experience with Arduino and programming?
Yeah.
Oh, yeah.
Eye-opening?
Yeah.
Do you like it? Do you want to learn more about it?
It was.
Not Arduino.
It was kind of rough at first because we never seen
Yeah.
anything like or worked with anything like that before.
Yeah.
Straight from nothing to see code.
Yes.
I would like to work more with this, but probably not with Arduino because like I kind of have like a handicap because I had to work on PSA stuff while we were working on this too, and like we were going to go to like regionals I think with TSA, and so I had to work on that instead of this. And then once I got in, I was like new to Arduino kind of because like they started on Arduino and like I was like, okay, what's going on here? And then like yeah, I kind of got rowdy from there. I was like.
Yeah, and then state also
State,
didn't help.
yeah.
Yeah.
So, on your final design, what improvements would you make if you were to continue?
Honestly, I think I'd get rid of this circle.
Yeah, I guess. I don't know. Because I came up with the circle part. Cause I'm that was me. We came up with the circle part.
Always trying to make it look pretty.
So yeah.
Yeah, I think that I agree. When we found out that the triangle was the
Most stable geometry.
most stable geometric shape, then we tried to include triangles into that so it'd be stable and, in theory. But
I mean, yeah, I guess if we can just make it an X shape, it's fine too, because it has the triangles, and simple is always great too, but better than being complicated.
Yeah.
So, y'all mentioned a few times that, like, in theory, it could be stronger. Have you ever thought about maybe testing it?
Yeah, let's go step on
You joke, but that's a test you could do. You know how much you weigh, and you know whether it would hold
just
up.
drop it off.
see if the
I
difference.
bet this would be great.
That would work.
This one would definitely break. This is like the most.
Yeah, so
That was the first one.
yeah, so
And
like, it got
That was
from
when
here
it was
to here.
fast.
And then to there.
all of your models? What do we call them?
Prototypes.
Artifacts.
Don't break your artifact.
Yeah, Emily's gonna go squish it over there.
I already switched this.
Very good. Thank you.